Hey everybody, it's Mark Vogt and welcome to another segment of Topics for Consultants, where we try to teach you topics that you need to know in short order as opposed to taking a long time. Oftentimes consultants have to learn to be an expert at something literally with 24 hours notice. If you're a consultant, you know exactly what I'm talking about. If you're a consultant, this is the kind of topic that you want me to treat. Today's topic is going to be, what is big data? You'll find a lot of common answers. A lot of common answers all say big data is any kind of data possessing the following characteristics: high volume, or high variety, or high velocity. They call those the 3 V's of big data. My problem is, I don't find this a very satisfying answer. It still hasn't told me, what does it mean to be big? You've just said it's got high volume. That just means there's, what, a large throughput going through, or there's a whole lot of it? But what does that really mean? I mean, what makes it big? And what we're going to try to do in the rest of this board in the next couple of minutes is that Mark's going to show you his own rendition, his own way of looking at what big data really means and why we actually need cluster computing to both store and to process that big data. So let me get rid of this with all of the text on here, because I'm going to need all of this space. And let's start drawing what a cluster looks like so that we can start understanding why we need a cluster in order to handle big data. A typical cluster is made up of, and I'll use, let's say, 3 nodes, 3 servers that make up my cluster. A cluster is going to be made up of 3 servers, typically running Linux these days, although with Azure they're doing a better job of it. There, we've got 3 servers, not necessarily the same size. What's important to know is that inside each one of these servers are going to be a set of resources. You're going to end up with the CPUs, on each one of them. And for now, we're going to say that they have the same number of CPUs. It's always a good idea to have commonality across all of your nodes. Uniformity makes it easier to swap parts in and out, keep your inventory down. Why am I putting the CPUs on both sides of this computer, of each of these servers? We're going to find out in just a short order. In addition to CPUs, other computing resources include RAM. We're going to draw little blue sticks. They'll look like this. So square things are going to be CPUs, rectangular things are going to be my RAM, and lastly in red we're going to draw disks, because every single computer typically has some kind of magnetic media storage, SSDs, or even electronic, something like that. It's going to have CPUs and it's going to have RAM. And this is the important part. So each one of these nodes in the cluster, each one of these servers that is participating in this cluster, is going to have resources available to it. It's going to have CPUs, it's going to have RAM, and it's going to have a disk. And there's 2 sides to this. There are the part, I'm going to draw a boundary through here. This is an imaginary boundary that we're going to call this. In fact, I'm going to draw a little line like that. This is going to be node 1. This is going to be node 2. This is going to be node 3 in my cluster. And we're going to have what I'll call the local side, or the local resources. And then we're going to have this side, which we're going to call the cluster resources. So far, so good. What happens is this, that inside any one server, that set of resources that it possesses, some of them are going to be set aside simply to drive the server itself. There's going to be 1 CPU, let's say, 1 CPU, some RAM, and 1 local disk that is set aside for the operating system and for the apps. On each one, This is just so that it can even participate in a cluster. The other half of the resources, the other portion of the resources, are going to go and be what it donates in order for that node, that server, to participate in the cluster. And there are going to be CPUs and RAM that are available only for the cluster to use, and the cluster's resource manager, typically something called Yarn, but we'll deal with that later. But the cluster application, the cluster operating system, is going to be responsible for managing these processing resources and for managing these storage resources. That what happens is that all of these disks taken together, even though they're a part of individual nodes, they're set off to the side. They have nothing to do with the operating system of the server itself. They're raw disks. They're completely unformatted. They don't even know what they have for an operating system or a file system on there. This becomes cluster storage. And this cluster storage is seen as one massive volume that in most technologies is going to look in like MapR technologies, which can make this look like it's part of a Linux file system. Then this entire array of disks, this cluster of disks, is actually going to be looking at, you can find it under MapR My Cluster root, and everything right here, this is where the cluster storage starts. It's all one massive drive. Now, why is that important? Back to what we were talking about. It's about big data. Big data is data that comes from high volume, from high variety, from high velocity. But what you can think of it as is this: it's data that's so big it doesn't actually fit on any one disk. Imagine that you had a massive file, so massive it couldn't fit on this disk. It couldn't even fit on these two disks. In fact, it's so large that it actually has to fit like this. And that there's something called sharding that splits that file, that splits that, let's say it's an Excel spreadsheet from hell. It is literally got 1 million columns in it, and it's got 5 billion rows in it. So 1 million columns and 1 billion rows. It cannot fit on an individual disk. What you need to do is shard it into pieces and store those shards on individual disks. And that is what is meant by big data. Because not only will that large file, petabytes, exabytes, zettabytes, gargantuan files, not only will it only fit on multiple disks in a cluster, it cannot fit on any one disk. It cannot be processed by any one set of resources on any one server. So that by sharding that file across multiple disks all participating in one single cluster storage, we can also utilize these resources to process only this portion. And we can use these resources on this node to process this portion of the file, and we can use these resources to process this portion. So that ultimately what cluster processing becomes, we can say that cluster computing equals storage plus processing. Hopefully that'll fit on my video when I get done. So that if we take a step back and say, what's big data? Big data is generating file sizes that are so large they have to be spread across multiple disks. In addition to being spread across multiple disks, in addition to being stored across multiple disks, they have to also be processed by the resources available in multiple servers. And when we've developed, now that we've developed cluster technology, the ability to store in a cluster and process using the cluster resources is what big data is all about. Hopefully this insight gives you a little bit better handle on what is being meant by big data. That you're dealing with large file sizes. Is it always large file sizes? No. Sometimes it's just literally trillions of small messages, but it still requires the ability to store on numerous disks because the trillions, the gazillions of tiny files won't fit on any one disk either. They cannot be processed by any one server in real time, so that you need to harness the processing power of a cluster of servers in order to accomplish that storage and that processing. Hope you guys enjoyed this particular video. Coming up next is that we're going to start digging in a little bit on some of the tools that are actually used as part of this cluster storage. Because in the long run, in the end, what really happened in the last 15 years is some people were trying to solve a parallel processing problem, and they inadvertently, my interpretation, they inadvertently built a cluster operating system. They didn't realize it until it was done, and we'll talk later in the next episode on what an operating system is, what a node operating system is versus a cluster operating system, and you'll start to better understand how we arrived at cluster computing. This has been Mark Vogt with Topics for Consultants. Hope you enjoyed this particular episode and found it useful. Feel free to give me hints, give me a thumb up, give me some comments. Please subscribe to my channel. Thanks. Bye.